Okay, we have to solve this inequality. So, with inequalities, you can treat the greater than or less than, or greater than or equals or less than or equals sign, mostly as an equals sign, okay? So pretend that's an equals sign and you can rearrange them just using your normal algebra skills, okay? The only time it behaves differently is when you have to multiply both sides by -1. I'll tell you what I'm talking about. Okay, imagine we had something like -a is greater than 2, okay? So we want to solve this, we want to get a is something greater than, less than, whatever, something, okay? So we've got to get a by itself. So if that were an equals sign, simple, right? We just multiply both sides by -1 and we get a equals -2, okay? Now we're still going to multiply both sides by -1 to get a by itself. We want plus a, not minus a. But like I say, this is the only time that inequalities behave differently. When you multiply both sides by -1, you have to flip the inequality. So we're going to multiply that by -1 to get a, but because we're multiplying by -1, we have to flip that, so it goes that way round instead. 2 times -1 is -2. So what that means is, if -a is greater than 2, therefore a is less than -2, okay? So that's a general case. Maybe we'll have to use it in this particular question, maybe not, don't know yet. But just remember that for inequalities, whenever you multiply both sides by -1, you have to flip the inequality, okay? Right, let's do the question. So, first thing, let's multiply out the bracket. So we get, therefore, x squared is greater than 3x. 3 times 6 is 18. Right, it's looking suspiciously like a quadratic, isn't it? So let's get everything on the same side and leave 0 on that side. So we're going to take the 3x over here by subtracting 3x from both sides. So we get x squared minus 3x. And we're going to subtract 18 from both sides, get that over here. Minus 18. And is greater than 0. So thus far, the inequality is behaving just like an equals sign, okay? Right, so we've got this quadratic. What do we normally do with quadratics? We're going to factorize it. So let's do that. There's no number in front of the x squared, so it's just going to be x and x. We're looking for two numbers that add to give minus 3 and multiply to give minus 18. Can you think of them? I think it's going to be 3 and 6, because if we go plus 3 and minus 6, they do indeed multiply to give minus 18, and plus 3x minus 6x gives you the minus 3x. Or plus 3 minus 6 gives you minus 3. So there we go, we factorized it. Where do we go from here? Well, if that were an equal sign, we'd just say x equals minus 3 and x equals plus 6. Those are the solutions, right? But we have to do slightly more work because it's an inequality. Not much. Don't worry too much about it. We're just going to do a quick sketch, okay, of this quadratic. So let's look at it here. Let's pretend. Well, okay, no, we'll pretend in a second. We'll just sketch it first. So it's plus x squared, so it's going to have that kind of shape. Now, okay, we're going to pretend right now. We'll pretend that that is an equals, okay? So you've got x plus 3 times x minus 6 equals 0. If two things multiply to give you 0, then either that is 0 or that is 0. And this is how we get the solutions. Therefore, if x plus 3 is 0, therefore x is minus 3. And this tells you where it crosses the x-axis. So when that's equal to 0, we pretend it's equal to 0 to find out where the graph of the quadratic crosses the x-axis. So it's going to cross the x-axis at minus 3 and plus 6. So it's going to look something like that, where that is minus 3 and that is plus 6. Okay? I'll just go over that again. When you've got to this stage, pretend that equals 0, and at those points, when that's equal to 0, solving that tells you where the quadratic crosses the x-axis, okay? Because the quadratic equals 0 there and there, okay? Y equals 0 there and there. So essentially what you're doing, we're plotting the graph of y equals x squared minus 3x minus 18, okay? And y equals 0, pretend that's 0, at x is minus 3 and x is plus 6. Okay, let's move on. The point of doing this is we've got the sketch of this quadratic. And now we can go back to this being greater than 0, what it actually is. What does it mean? It's saying, where is this quadratic greater than 0? Well, it's greater than 0 in this region here, okay? Again, pretend it's y equals x squared minus 3x minus 18, or y equals x plus 3 times x minus 6, in which case y is greater than 0 here and here, okay? Y is less than 0 for all these values, right? But it's greater than 0 for all these. So what values of x does that correspond to? Well, we know it crosses at minus 3 and plus 6. So therefore, this is true where x is less than minus 3, okay? And where x is greater than plus 6. Okay, and that's the answer. Good. I'll just go over that last bit one more time. When you've got it in this shape, in this form here, okay, do a sketch, pretend that equals 0 to work out where it crosses the x-axis at minus 3 and plus 6, okay? And then look at the greater than or less than sign. It wants values of this greater than 0. So that means all the parts of the sketch above the x-axis, okay? And they correspond to x values, those regions, x values less than that point there, minus 3. So x is less than minus 3, and x is greater than plus 6, because for all of these values of x greater than plus 6, we have values of y, or this thing, greater than 0. Okay. You don't have to fully understand that. You just need to just copy the procedure I've shown you, do the sketch, look at that, and say, okay, we want values bigger than 0, so it's there, therefore it must be x less than minus 3, and x greater than plus 6. Just follow the procedure, and that's how it's done.